All right, so section 10.4. We're going to start working with matrices a lot more, and that's going to include some of what's called the algebra of matrices. So we're going to add, subtract, and multiply matrices. We can't really divide matrices. Matrices have a lot of good applications. Let me just kind of mention some of them with respect to photography. A lot of times images will be digitized, and then once it's digitized, you can represent that image as a bunch of numbers, and that those set of numbers become a matrix. Now obviously you'd probably want to make your grid a little bit finer in order to reproduce that image, but I think you get the general idea. What happens then is that you can do operations on these matrices, and those operations can do things that you're familiar with from Photoshop. You can enhance the contrast, you can reflect things, copy things, etc. So lots of good applications, not the least of which would be writing secret codes. But of course there's a lot of good ways to write secret codes. Let's start with some addition and subtraction. So problem number 10 gives you the matrix 0, 1, 1, 1, 1, 0 minus the matrix, that first one looks binary. The second one certainly isn't binary. 2, 1, 0, 2, 1, negative 1, 1, 3, negative 2. Now, one important thing that you need in order to add or subtract matrices is to have matrices with the same dimensions. What are the dimensions of these matrices? Good, 2 by 3. All right. What's nice about adding and subtracting matrices is that it's kind of like what you might think. We're going to take 0 minus 2, subtract, corresponding terms, and get negative 2. 1 minus 1 is 0. Be careful with the double negative here. 1 minus negative 1, 2. How about the bottom row? 0, negative 2, and 2. Yeah, everyone wants to say, 2. Yeah, there we go, 2. All right, so let's try another one. Problem number 12. Now, another thing that we can do with our matrices is multiply them by a constant. So problem number 12 looks like this. 2 times 1, 1, 0, 1, 0, 1, 0, 1, 1. So back to that binary matrix. And the second matrix is 1, 1, 2, 1, 3, 1. Now let's talk about the first part of this, which is really about as far as we're going to be able to get. When you have a constant in front of the matrix, really what that implies is you're going to multiply everything in the matrix by that constant. So I'll rewrite that as 2, 2, 0, 2, 0, 2, 0, 0, or excuse me, 0, 2, 2. So this becomes 2, 2, 0, 2, 0, 2, 0, 2, 2. What's the dimensions of that first matrix? Good, 3 by 3. And the second one is a 3 by 2. So unless those dimensions match, then you can't add them. So that's it. That's as far as we can go. We cannot add those two matrices together. Now, I hope you're getting a little bit of a flavor for working with these matrices, but to do this stuff by hand becomes a real pain. So let's learn how to do it on the graphing calculator. So take out your graphing calculators, and we're going to plug in some matrices for the next series of problems. So let me kind of zoom in a little bit. So let's plug in matrices A, B, C, and F. So A, B, C, and F. Now, how do you plug in even one of these matrices? Well, let me help you out with that. On the left-hand side of your calculator, right above the X inverse key, you'll see the matrix key. So we hit second matrix, so second X inverse. We want to enter matrix A, so go over to Edit, use the arrows across the right or across the top of your calculator to move to the right. When you press enter or 1, you're going to edit matrix A. What are the dimensions of matrix A? 2 by 2. When you type those in, it'll adjust that. Just go through and press enter after you put in each of those elements, each of the elements of that matrix. When you're done, exit this. And this is kind of an important step because a lot of people are anxious to do determinants or inverses and stuff like that. You don't want to do that while you're editing your matrix. So hit the second button and then the mode key right next to it. Second and then quit. Let's enter matrix B. So go back to that matrix menu, second, and then X inverse. Go over to edit. What are the dimensions of matrix B? Yeah, 2 by 3. So 2 rows, 3 columns. 3, 1/2 I'll enter as 0.5, 5, 1, -1, and 3. And again, once you're done, you want to quit. You want to exit. So hit the second button and then the quit key. Matrix C is another 2 by 3 matrix. So let's enter that. Hit second and then matrix. Go over to edit. Go all the way down to C. From the edit menu, make sure you're editing matrix C. Enter in a 2 by 3 matrix. And then the elements are 2. -5/2, so I'm going to write as a decimal, -2.5. 0, 0, 2, and then -3. Finally, let's enter matrix F. I'm not sure if you want to enter it in the space provided for F or if you want to enter it in D, doesn't really matter. But exit out of there. So again, press the second button and then quit, or second and the mode key. Let's go back to second matrix. Maybe just for ease of keeping up with things and trying to avoid some confusion, we'll put matrix F in matrix F. But you got to go to the edit menu first. F is a 3 by 3, and I want 1, 0, 0, 0, 1, 0, 0, 0, 1. So let me walk around. If there's some problems in getting these things, then let me know. So we're all good? Getting these things entered? All right. Let's make our calculator do some of these things. Okay, so one of the things your calculator can do would be to say multiply things by a constant. And let's just check that out with matrix B. So if you wanted to type out or print one of the matrices, then go back to the matrix menu, hit the second button, then the X inverse key. So there. And simply type out the matrix we want. So let's type out matrix B by pressing 2 and then enter. And there's matrix B. But I can also multiply this by a constant. So throw out a constant you want to work with. 2? All right. So let's do 2 times B. So 2, then you got to go back, and I know it's not, quite so easy, but there's 2 times B. You can do, or I could do, if I wanted to be fancy, I can hit times, and it's going to take my previous answer and multiply it by something. So let's do times 3 here. So it's nice. It's doing a lot of grunt work for us.
Can you not divide?
Well, you can't really divide matrices. You can multiply a matrix by a constant. Say, for instance, I could hit divide by 6, and it's really going to be, it doesn't like that. Let's see, I can take times parentheses 1 divided by 6. I think it'll take that. Yeah, there you go. So that gets us back to our original matrix. But as far as division is concerned, you can't really divide matrices. Matrices are kind of strange, and we're going to see that especially when we start working with multiplication. Matrix multiplication is much different than you might expect. In fact, let me pass out a little handout on that so that when we get to that, we'll be ready for it. All right, well, let's do a few of these things here. Now, we'll start with C minus B. That's problem number 24A, or excuse me, yeah, it's problem 24A. So if I want to do C minus B, basically at this point, it's just typing it in. Go back to your matrix menu, go down to C. There's matrix C. Don't hit enter yet. Hit the minus key and then do C minus B. Nice. So that stuff we were doing by hand in problem number 10, you can make your calculator do. And you're probably much better off doing it on your calculator, assuming that you entered things correctly. We can also do a little bit more here. For instance, part B, 2 times C minus 6 times B. You might want to check yourself that you can do that calculation. 2C minus 6B. So it's nice that our calculator can save us a lot of grunt work here. I mean, you could do it by hand. There's nothing wrong with that. I would just hope that you take advantage of the technology that is available to you. Okay. How are we looking on that first one? Or are these first couple here? Looking all right? Do we need to do 26A? I mean, you're able to follow along with these commands on the calculator? All right, so we'll skip that one. Let's go down to problem 33A. Now, 33A, before we do that, let's kind of make a prediction. So 33A asks us to calculate A squared. So the matrix A times the matrix A. Let's take a look at this. A squared. Would it be reasonable to assume that I would get 4, 25, 0, and 49 out of A squared? Seems reasonable to expect that. Let's check it though. So type matrix A, and then hit the squared key. And let's see what we get. Uh-oh. Did we get what we expected? Not exactly. No. So it's a little bit different. And if you had done, say, A times A, which is really what A squared is, you get that same thing. So there's something going on with matrix multiplication. It's not just as simple, straightforward. All right, if I'm multiplying A times A, I'll multiply 2 times 2, and then the 5, negative 5 times negative 5, etc. It's a little bit more involved. So that's why I gave you a little bit of a handout. So we got a few matrices on it, and maybe we'll practice a couple based on the handout. We'll see. But there's an interesting thing about multiplying matrices that is going to be new to you. You can't always multiply whatever you want. Now that's not true with the numbers that you've worked with. You can always multiply any two numbers. You can divide them as long as the bottom one's not 0. But with matrices, the inner indices must match, otherwise you can't multiply the matrices. So what do I mean by that? Suppose you're multiplying a matrix which has dimensions n times m by an m times p. these are your inner matrices or your inner dimensions. These have to match. If they don't match, that's it. You cannot multiply these things. If they do match, the size of the product you get is right here. That's going to be the size of your new matrix. So, wow, kind of strange. Let's check it out. Let's see about multiplying a couple matrices. Let's start out with the example here. A times B, where A and B are defined up above. What's the dimensions of matrix A and B, for that matter?
2 by 3.
All right, so we got a 2 by 3 times a 2 by 3. If you look at these, they're not equal. The dimensions don't match, so we can't multiply them. So that's kind of strange. Let's take a look at, let's see. Let's take a look at a couple of the problems we got in our, now, let's see. Let's do one more from the handout here for the moment. What if I tried to multiply B times C? Do those line up correctly?
Yes.
Well, the dimensions of B are 2 by 3, and C is a 3 by 2. So the inner dimensions match, which means you can multiply them. And when you multiply them, you're going to get a 2 by 2 matrix. Now here's something pretty strange. What if you multiplied C times B? Can you do that? C is a 3 by 2. B is a 2 by 3. So we can multiply them together, and we'll get a 3 by 3 matrix. So what's unusual about that?
There's a number that appears normally it doesn't matter what you multiply.
The order.
What's in front or...
Exactly. What you're familiar with is that when you multiply two things together, it doesn't matter which order you multiply them, right? 7 times 8 is the same thing as 8 times 7. But it should be clear that these two things are much different animals. On the one hand, you get a 2 by 2 matrix. On the other hand, you get a 3 by 3 matrix. So, wow, they're just very different. In some cases, you'll be able to multiply in one direction and not at all in the other direction. So, matrix multiplication is not commutative. It matters what order you multiply things in. So, okay. Well, a quick little mention here. Your calculator knows how to multiply these matrices. And if you try and multiply things that don't line up, it'll give you an error. So in our calculator, suppose we tried to multiply A times B, matrix A times matrix B. Do those dimensions line up? Yeah. So in the one direction, you've got a 2 by 2 times a 2 by 3. So they line up, and that would work. Let's try it. So matrix A, and you don't have to put in a times or anything like that. It's understood there. If they're right next to each other, you'll be fine. So there's matrix A times matrix B. Can I multiply them in the other direction, though? Can I multiply a 2 by 3 times a 2 by 2? No. Those don't match. That's it. So let's see what happens when we do it on our calculator. Matrix B times matrix A. Your calculator is going to give you a little reminder that you can't do that. Dimensions mismatch. So it's telling you what we saw by looking at the dimensions. They don't match. Okay, so how do you multiply those matrices then? Well, let's look at it with the example here. I've got a 2 by 3 times a 3 by 2. So the dimensions of the product are going to be what? 2 by 2. So it's going to be a 2 by 2. Thank you. Now let me call this matrix C, just to have some notation for this. And matrix C, let me give you some more notation. We'll call it C sub I j. So it's going to be the ith row and the jth column. So this matrix is going to be made up of elements that look like this. It's going to be C row 1 column 1, C row 2 column 2, C row 2 column 1, C row 2 column 2. We got to figure out what these numbers are. So multiplying by matrices, I don't know, it's going to be kind of different for us. But the product, these are right down here. So let me do this. Let me kind of add a little color to this. All right. So this is C11. This is, well, I should maybe calling it C11 is not the best, but C12, C21, C22. So this is your 2 by 2 matrix. Where am I getting these numbers? Well, the first set of numbers is from the row of B. First row of B. And the second set of numbers comes from the first column of C. So when you multiply these two together, you're going to take this times this, plus this times this, plus this times this. And that's going to be C11. If I want to get C12, I'm going to multiply the first row of B times the second column of C. So negative 3 times 1, 12 times 3/4, 8 times negative 5. And that's listed for us down here. So each of the elements in this product come from a row of B and a column of C. And when you multiply these out and add them all up, you get that product matrix. They used there's a Q on the handout for the product. Let's try things the other direction. So if I did C times B, that's going to be a 3 by 2 matrix times a 2 by 3 matrix. What are the dimensions of the product going to be? A 3 by 3. So let's call the product, let's use the Q that they used. Q here. So the elements of this matrix, let me kind of label them this way. I'll go Q11, Q12, and Q13. How about the next row? What should I start out with? Q21. Cool. Thanks, Rebecca. And then Q31, Q32, and Q33. Now each of these terms comes from the product of a row of C and a column of B. So for instance, if I want, and you can pick any elements of this matrix. If I want Q23, I'm going to be multiplying row 2 from C times column 3 from B. So 4 times 8 and 3/4 times 1/9. And that's the same way throughout the whole matrix. multiply a row from the first matrix times a column from the second matrix. And that's all done for us over here. When you add them all up, you get something like this. Now what I want us to do is practice one or two of these by hand, and then we'll do it on our calculator for a little bit. But for starters, let's practice doing a couple by hand. We'll start with sorry about this. Let's do a simple one to start with. We'll do b times f from our work earlier. So going back to the matrices that we had here, b and f. Let's multiply b times f if we can. So let me rewrite those up here. Matrix B was 3, 1/2, 5 times 1, -1, 3. Matrix F, kind of an interesting looking one. We've got 1s on what's called the main diagonal and 0s everywhere else. So let's see if we can't do b times f. Well, matrix B is a 2 by 3 times matrix F, which is a 3 by 3. So it works. We can multiply b times f. And we're going to get a product. Let's call it matrix Q. What are the dimensions of matrix Q going to equal? 2 by 3. So 2 by 3. Let's write ourselves generously spaced 2 by 3 matrix. So this is Q11. To get what's in this element, I'm going to multiply this row times this column. So it's going to look like this. It's going to be 3 times 1 plus 1/2 times 0 plus 5 times 0. I have to add all those up to get what's in that first element. I'm going to do likewise to get all the rest of these. So this is Q12. So I want some help on some of the rest of these here now. What do I multiply together to get what this is going to be? All right, 3 times 0. So this times this. 1/2 times 1, good. And 5 times 0. Excellent. Keep going. Do Q13, Q21, Q22, and Q23. you're done simplifying. You should see something that looks kind of familiar relative to this problem. Yeah, you should end up with matrix B again. And that's saying something special about F. We'll talk about that. Bless you. All right, so I'm gonna walk around a little bit, see how you're doing on these. Same thing for each position in the matrix. How you doing over here? Comfortable? Comfortable with these? All right. Good. You can check it by plugging into your calculator too. There's nothing wrong with that. Chances are that I might have you show me one multiplication by hand on an exam. I don't know. We'll think about it. But for right now, let's make sure that you understand what to do here. Q1, 3, that's going to be row 1, column 3. So 3 times 0 plus 1/2 times 0 plus 5 times 1. Row 2, column 1. So row 2, column 1. 1 times 1 plus -1 times 0 plus 3 times 0. and 2 more, row 2, column 2. So that's going to be 1 times 0 plus negative 1 times 0 plus 3 times 0. Wait, negative 1 times 1, sorry. And then 3 times 0. And last but not least, 1 times 0 plus negative 1 times 0 plus 3 times 1. So the interesting thing that you get when you're all done is you get the matrix that you started with. You get that thing back. So matrix F has some alternative names. It's called I3, for instance. It's the identity matrix of order 3. So it's always going to be a square matrix with 1s on the main diagonal and then 0s everywhere else. So for instance, I2 would look like this. 1, 0, 0, 1. That's I2. The matrix, the identity matrix of order 2. And so on. You can imagine identity matrices of every dimension. So see if you can't figure out what I4 would look like. So try and write down for yourself I4. Okay, so I4 should look like this. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. This is going to play an important part in our work in section 10.5. So for right now, though, we're just worried about multiplying some matrices together. Let's practice with a couple other ones, a couple smaller examples. This one's not in the book. Matrix A is going to have 2, 1, 5, 3. And matrix B, let's see, what do I want for matrix B? How about 3, negative 1, negative 5, and 2. So I want one half of class to do A times B, and the other half of class to do B times A. So the left half of class, starting from Jeff over, can work on A times B, and the other one can do B times A.
So where do I go?
You're left.
But am I in that group?
You're inclusive. You're inclusive. All right. So, all right. You guys do B times A. Yeah. You can do A times B. So on an exam, if I asked you to show your work, I guess I'd kind of expect something like this. C11, first row of A, first column of B, so 2 times 3 plus 1 times negative 5. Row 1, column 2, 2 times negative 1 plus 1 times 2. Row 2, column 1, so 5 times 3 plus 3 times negative 5. And last but not least, row 2, column 2, so 5 times negative 1 plus 3 times 2. Are we okay with all those numbers there? Let's try the other side here. So C11, row 1, column 1, 3 times 2 plus negative 1 times 5. C12, row 1, column 2, 3 times 1 plus negative 1 times 3. Negative 5 times 2 plus 2 times 5. And last but not least, C22, row 2, column 2, negative 5 times 1 plus 2 times 3. Now something interesting is happening in both of these. Yeah, in both of these you get 1, 0, 0, 1. 1, 0, 0, 1. In fact, I had a name for that. It was I2. So this is kind of interesting and special because typically when you're working with these matrices, matrix multiplication is not usually commutative. Usually it makes a difference what order you multiply. This time, both of them commuted, and we got a very special matrix called the identity matrix. Now what that means, and we'll see more of this in section 10.5, is that these two are inverses of each other. And we'll have to talk about that, and we'll learn some cool stuff about that. But for now, let me give you some homework. So for homework, try 9 through 15 and 23 through 41. Some of these, a few of them you should practice by hand. You should be able to multiply matrices by hand. I'm not guaranteeing that that's a problem that's going to be on an exam, but it might be. It'd be a short one, though. I wouldn't give you something like a 10 by 10 and another 10 by 10. It's going to be mercifully short. So section 10.4. Just the odds. Just the odds.